Yes, welcome back to Mr. Samuel's MTH classroom. In our previous class, we were able to cover definition of sets, infinite sets, and finite sets, null sets, equality of sets. So today we move to another important concept in set theory, which we call subsets. So what is a subset? A set A is called a subset of another set B if every element of A is also an element of B. If every element of set A is also an element of set B. Now, the symbol is this, which we read as A is a subset of B. A is a subset of B. Now, example. Let set A be equals to 2, 4, and let set B be equals to 2, 4, 6, 8. A is a subset of B because every element in set A is found in set B. Why? 2 is in set A and 2 is also found in set B. 4 is in set A and 4 is also found in set B. Definitely, A is a subset of B. A is a subset of B. A is a subset of set B. Good. Now, example 2. Let A equals to 1, 2, 3, and let's set B equals to 1, 2, 3. A is a subset of set B as well, because elements in set A also appears or is also found in set B. Now, let's observe 1 is in set A, 1 is also in set B. 2 is an element in set A, 2 is also an element in set B. 3 is an element in set A, 3 is also an element in set B. Fine. But the main important thing is that we have to note that every set is a subset of itself. Yes, every set is a subset of itself. And you have to pay attention to this as well. If A has the same element and the same number of elements as set B, if set A has the same element and the same number of elements as set B, definitely they are equal. If they are equal sets, so A can be a subset of B as well as B being a subset of A, because they are equal. That is it. So from there we can now move to our proper sets, our proper subsets. Proper subset is a set that is not equal to the original set. It is a set that is not equal to the original set. Now, example 1. A is 2, 3, 2, 4, and B is 2, 4, 6. Since A is smaller than B and every element in A is found in B, then A is a proper set or proper subset of B. A is a proper subset of B. Now, what am I trying to say? If you observe well, you will see that 2 is found in set A and 2 is also found in set B. 4 is found in set A and 4 is also found in set B. Definitely, A is a proper subset of set B. I know the next thing that will be in our mind, or the next question that will be in our mind is look alike with our subset. Yes, proper subsets and subsets look the same, but they are not the same. Why? A proper subset can never be equal, but subset can be equal. A proper subset can never be equal to another set, but subset can be equal. That is, a proper subset must be smaller to the original set. But in subset, you can have equal elements and equal numbers of elements. That is the different. Thank you. Now, moving to, and this is the symbol. This is the symbol. We know the symbol of proper subset. This is the symbol, proper subset. That is, it is not having equals to. You can see this symbol was having equals to. Why this symbol is not having equals to? This one is contained in or equals to. This one is contained in ordinarily. Are you getting it? So that's it. Let's move to the next one. Sorry. That the bottom part of the set I was trying to say. Now we are moving to the next one. That is example 2. That is my example 2. In my example 2, I have set Y as A, B, C and set Z as A, B, C as well. Now, do you want to tell me that set Y is a proper subset of set Z? No, set Y is not a proper subset of set Z. Why? Because they are equal. And remember, I told you a proper subset can never be equal to the original set. So if they are equal, automatically it should be a subset. You can say Y is a subset of Z, but you can't say Y is a proper subset of Z. That is it. Thank you. Now, comparable sets. Two sets are comparable if one is a subset of the other. Two sets are comparable if one is a subset of the other. That is, if they have something in common, or if one can be picked out of the other. Good. Now, example 1. Set A, 1, 2, and set B, we have 1, 2, 3. Now, since A is a subset, A is a subset of B, they are comparable. Why? Because we can find A and we can find 1 in B and we can find 2 in B as well. Definitely A is a subset of B. Is a subset of B. We can also say A is a proper subset of B. Is correct. Is correct. Yeah. Now, example 2. Set A is 1, 2 and set B is 3, 4. Neither A nor B is the subset of the other. Why? 1 is in set A, 1 is not in set B. 2 is in set A, 2 is not in set B. So they are not having anything in common. So they are not having anything in common. Good. The other thing we have here is universal set. This is the set that contains all elements under a discussion. Imagine we are discussing number 1 to 10, whole number 1 to 10, or natural number 1 to 10. Now, you know the universal set will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. Now, if A is having 2, 4, 6, definitely A is a subset of U. A is a subset of the universal set, because universal set is the mother set to every other set. Universal set gave birth to every other set under a discussion. Thank you. So the next one we'll be moving to is power sets. Power sets. A power set is a set of all possible subsets. That is the list of all possible subsets, or the set of all possible subsets. And the symbol is P of A. We represent it by writing this P of A. That's the symbol. Yeah. Now, example. Set A equals to 1, 2, and set B. Set A equals to 1, 2. Definitely, the subsets are, that is the subset of set A are empty sets. You can remember this from our previous class. Empty set 1 as a set, 2 as a set, 1, 2 as a set. All these are subsets of set A. They are subset of set A. Now, therefore, the power set of set A, the power set of set A will be empty sets 1 as a set, 2 as a set, 1, 2 as a set. Once you see this curly bracket, it means it is a set. It is a set. It is a set. You get it right now. And it has formula in solving question under power set. If a set has n elements, that is n number of elements, then the number of the subset will be 2 raised to power the number of the elements in set A. Are you getting it right? Now, what do I mean? If set A is 1, 2, 3, count the number of the elements in set A. That is, the number of elements in set A will be 1, 2, 3. That is, our n equals to 3. If our n equals to 3, definitely the list of all subsets will be 2 raised to power 3, which is 8. That is, the number of all subsets will be 2 raised to power 3, which is 8. Yes. Now, another one is disjoint. Disjoint sets. Two sets are disjoint if they have no common elements. If they have no common elements, for example, A is a set of 1, 2, 3, and B is a set of 4, 5, 6. You can see that there is nothing common between A and B. A has 1, B does not have 1. A has 2, no 2 in B. A has 3, then no 3 in B. Yes. Since it has no common elements, definitely A and B are disjoint sets. They are what? Disjoint sets. Good. Now, another thing. Let's go to example 2. If you have A as 2, 4, 6, B as 6 and 8, 6, 8 and 10. Since both contain 6, 6 is in A and 6 is in B, we can call them a disjoint set. They are not disjoint because they have a common element. They have a common element. Good. Let's quickly work this example. Let's work this example. Number 1, if A equals to A comma B, and we are told to find power set of A. Then number 2, if set Z equals to 2, 4, 6, 8, we are told to find the number of all the subsets. We don't need to waste time. The first thing you write is solution. It's a very simple thing. Solution. Now, number 1, we are given A equals to A comma B as a set, and we are told to find the power set of A. Power set of A means list all the subsets of A. Now, without wasting our time, our power set of A will be the first thing will be empty sets, comma, pick this as a set A, comma, B as a set B, comma, then AB as a set A, comma, B. So this is what we call the power set of A. You get it right? We've just answered the question 1. Now let's go to question 2. In our question 2, we are told to find, they said our set Z is 2, 4, 6, 8. Then we are told to find the number of all the subsets of A. We are finding number of all the subsets. We are not listing the subset. We are finding number. So what do we do? Very easy. Write your question. Z equals to what? Set 2, 4, 6, 8. Then we are told to find the number of all subsets in Z. Are you getting it? Now, the first thing we have to first get the number of Z. The number of Z is what? 1, 2, 3, 4 is 4. Definitely the number of P of Z will be equals to 2 raised to power 4. 2 raised to power 4, which is what? 16. Do you get it right? If the number of elements in Z is 4, definitely the number of the power set of Z will be what? 2 raised to power 4. You get it right. Thank you. So I meet you in the next class. Thank you.